Hello everyone, good morning. Am I audible? Yeah, perfect. Okay, so let's begin with the session here. Okay, in today's session here, let us try to talk about something called as comparator here. Okay, so in the previous session we spoke about comparable, wherein it was just used to compare the objects and sort them, right? So in today's session we are going to talk about something called as comparator here. Okay, so what is comparator used for? Again, comparator is also a predefined interface in java.util package. Okay, and this was introduced from JDK 1.2. Okay, so even comparable is an interface, comparator is also an interface. Comparable is present in java.lang, but comparator is present in java.util package. Okay, and comparable had an abstract method called as compare to, but comparator has an abstract method called as public is the access specifier, int is the return type, and it will call, okay, there is a method called as compare which accepts two objects here, object O1 and object O2 here. Okay, so if I specify generics here, it's it understands that okay, we are going to compare the specific type of objects here. Okay, comparator has an abstract method called as compare method. Comparable has an abstract method called as compare to. Okay, so this is how we are supposed to understand. And what is the job of comparator? Comparator job is for custom sorting. Okay, custom sorting over here. Okay, wherein we are supposed to compare the objects and sort them in one particular manner here. Okay, so this is what we are supposed to understand here. So we have a set of rules here, okay, wherein we have to understand here. Okay, so this is the entire process that we are going to understand. So what is comparator? Comparator is a predefined interface in which package? Java.util package. When was it introduced from? It was introduced from JDK 1.2. So from the second version of Java here, okay, I mean this comparator was introduced, and it also has an abstract method. What is that abstract method called as? That abstract method is called as compare here. Okay, comparator is an interface, meaning it should have abstract methods, right? So it has an abstract method called as compare. And the syntax of compare method is public means everyone can access, int means positive number, negative number, 0, and it accepts two object type argument here. Okay, so how do we compare objects and sort them with the help of comparator is what we are supposed to see in today's session. Later we will understand the difference. Okay, later we will tell sir why comparable, why comparator, I will tell you later. But as of now we have to understand the process here. Okay, now you have to tell me the object, guys. Okay, so we have a project called as collection framework. We're done with 6 days of collections here, and today is my seventh day, wherein I will just write it as custom sorting. Default sorting comparable, custom sorting comparator. Okay, so we have this custom sorting. Under custom sorting, I will have a class, and the class name is I will just write the class name as student here. Okay, I will just write the class name as what? The class name is student here. Okay, now right. Okay, so just I'm waiting for the class to be loaded here. Yes, so we have a class called a student, and it will have a couple of properties, that is age and the name as well. Okay, student has two properties, that is age and name, and I want to initialize it with the help of a constructor as well. Okay, so let me just try to initialize that respective variables with the help of a constructor. And I will also override the toString method because I do not want the fully qualified class name, rather I just want the actual content to be passed here. Okay, so that's the reason I have overridden the toString method as well. So this is like student age equals to so and so. The output will be in this particular manner. See, if you just try to just sort it out, the output will be something like this. See, student. Okay, if you want to just look at the output here, it will be student underscore, I mean brackets, age equals to, the age will get concatenated. Imagine it is 25. Okay. After that here, okay, comma, name will get equal to, okay, that would be the name here. That would be Tom here. Okay. And that would get concatenated over here. This would be the expected output here. Okay. So that's how the output will look like. Okay. Student age 25 name. That's the reason I'm concatenating it in this specific manner. So you can, you can override it in whichever manner you want it. Okay. So in simple terms, I have a class called as student. It has two variables. Okay. Wherein I'm initializing both the variables with the help of a constructor, and I have overridden the toString method because I do not want the string representation, rather I want the actual data to be printed. So that's the reason I'm overriding the toString. Now here I will have a class called as sort student. Okay, I will have a class called as sort student, and I will have my main method wherein the execution will begin from. So now under that, I will create three student objects. Student S1 equals to new student of. Okay, student S1 equals to new student of. And the age of the student, I'll pass it as 22. And the name is, I'll pass it as, I'll just write it as whatever name you want. I can just write it as, which name? We'll write it as Dinga only. Okay. And then I can have any number of student objects here. Okay. So let me just add a couple of more. Okay. S2 and S3. He is 23 and he is 21. And his name is Gundu. And his name, we'll write it as Tom. Great. So now this is what we are supposed to do it over here. And then now here, I will create an object of treeset. Treeset T equals to new treeset of. Okay, I'm just creating an object of treeset over here. Okay. And treeset is a predefined class in java.util package. So we are supposed to import it as well. Okay. So let me just, treeset. I will import it as well. So I will add all the student objects one by one into my treeset. S1 t dot add of S2 t dot add of S3. I'm adding all the student objects into my treeset. Now I want to traverse it. Okay, before that, my treeset has to store only student objects, not employee, not monkey, not donkey. So I will make use of generics and tell treeset is storing only student objects. So optionally, I can make use at the constructor side as well. I can make use of generics and tell treeset, please allow only student objects. Okay, don't allow other types of objects. So I have told this respective data here. Okay, and over here, okay, and over here, I will pass student object I'm traversing, student std colon from which treeset t. Now, quickly, I don't want anyone giving wrong answers here. Okay, if you give me wrong answers, I'm going to kill you seriously. Okay, we have done similar kind of programs hell lot of times here. Okay, so what should be the output of this entire process here? Okay, wait, if you don't want the toString method in this particular manner, override it. Age, so I'll tell it as age plus give a space plus name. Okay, I'll just override it. So now what will be the output of this entire program here? Treeset will sort, guys. Keep in mind here. Okay, it will sort. But what will be the output of this entire program here? Think and tell me. I'm waiting for answers. Waiting for answers. Waiting for answers. Everyone are telling class cast exception here. Are you sure we will get class cast exception here? Yes. Okay. You should be confident enough here. So you will definitely get class cast exception. You shouldn't forget it. Okay. Very good. Okay. So, good job. Good job. Okay. So here we will definitely get class cast exception. And what is the reason we are getting class cast exception is very, very simple. Sir, when you add an object into treeset, okay, automatically it will go in search of compare to method internally. When you add an object into treeset, by default, okay, by default, it will go in search of compare to method internally. Now, since we are adding student objects over here, it goes in search of compare to method in student class. Do we have compare to method in student class? No. Then how will it get compared and how will it sort here? We have not at all defined the sorting logic. We haven't told, hey, please sort the student based on this criteria. I have not told how will it sort. So that's the reason we are getting class cast exception. So now I have to compare the student objects, but I shouldn't make use of comparable. Rather, I have to make use of comparator. So what is the rules here? So rules here is, first design a new class in such a way which implements the comparator interface and specify the generic style. So it's telling if you have to compare the student objects and sort them with the help of a comparator, custom sorting. Okay, why comparator? I'll tell you later. Why comparable? I'll tell you later. But now we are just going to understand how we are comparing the objects with the help of comparator and we are trying to sort them. Okay. So firstly, we have to design a new class which implements the comparator interface, and we have to specify the generics type of which objects we are going to compare. Let me just implement rule number 1 here. Okay. Rule number 1. Control N. I create a class. The class name is sort students by age. Okay. Sort students by age here. Okay. I created a class that is sort students by age. That class, whichever I designed a new class which will implement the comparator interface. Okay. Which implements comparator, and I have to specify the generics type of which objects I am going to compare. As of now, what is the objects I'm going to compare? Student objects, no. I have to specify the class type as student here. And the second step is import the comparator interface. Why the hell should be imported? Because sir, this guy is present in java.util package, sir. So we have to import the comparator interface. So what are the two rules we understood? Create a new class which implements the comparator interface and specify the generics type of which objects I'm going to compare and import that respective interface here. Clear? Second rule, a third rule is, when a class is implementing an interface, we have to override the abstract method, no? So comparator has an abstract method called as compare method. So we have to override that compare method. Public is the access specifier, int is the return type, compare is the method name, and it accepts two arguments over here. So since I have explicitly told I am comparing student objects here, I have to write the generic type as student. Student X, comma, student Y here. Okay. So student X is nothing but the object which is going to get inserted, and student Y is nothing but the already existing object here. So therefore, I will tell return, because the return type is int. Return, I will tell the current object's age minus the already existing object's age here. Okay. And this is an overridden method. Okay. And I will get the expected data here. So rule number 3 is, okay, see what am I doing? Override the compare method by specifying the business logic of for comparing or sorting. So I have to compare, right? So I will override the compare method, but by providing the business logic for sorting here. Rule 3 done. Sir, what is the working of it, sir? I will tell you later. Okay, I will tell you later. But as of now here, as of now, when I execute, will I get the output here? No, I will not get the output. Still, it will give class cast exception. Why? Because now I am not making use of comparable and compare to method. But when you add an object into tree set, by default, it will go in search of compare to method. But now I have to tell, please don't go in search of compare to method. Rather go in search of compare method, wherein the business logic for sorting is written. So therefore, I have to create an object of a class wherein the sorting logic is written. Sort students by age, age equals to new age of. I create an object of the class which wherein the wherein the logic is written. Okay, the logic for business logic for sorting is written in the sort students by age class, right? I have to create an object of that respective class, and that object reference here, I have to pass it to the constructor call of the tree set here. Since I have passed the age over here, okay, the object reference of the class which has the sorting logic, now the tree set will go in search of compare method, not the compare to method. So now when I execute it over here, can you see here? The sorting has happened based on the age here. I'm getting the expected output. Sir, what the hell did you do, sir? Oh, I will explain it. Don't worry, guys. Okay. But quickly, I hope you all understood what is present in the student class. Correct? Student is a class. It has two attributes, age and name. And I have initialized it with the help of a constructor because while creating an object, I will pass some name and age that will get initialized in the object. And I have overridden the toString because I do not want the string representation. I want the actual data. I want the actual content to be printed here. Okay. And then in sort student class, I have created three objects of student. So let me create three objects of student here. Okay, just let me, create three objects of student. Okay, so three objects will get created, guys. This is object one. Okay, similarly, I am going to create three objects. This is object two and this is object three here. Okay, so three objects of student will get created. So addresses are 111, S1 is pointing there, 222 and S2 is pointing there, and 333 and S3 is pointing there. Each and every object will have two attributes, age, name. Correct? Age and name will be the two attributes. Each and every object will have age, name. Okay? And here also age and name here. Clear? Great. So the age of the first student is 22, then it is 23 and 21. And the name here is Dinga. Okay. Here it is Guldu and here it is Tom. Okay. Dinga, Guldu, Tom. Okay. Age is 22, age is 23 and age is 21. So now here, now it will not go in search of compare to method. It will go in search of compare method. And what is the logic for compare method I've written? Public is the access specifier, wherein every object, everyone can access it. Int is the return type, wherein it returns +1, -1, 0, and the method name is compare. Okay, open parenthesis close and open curly braces close here. Okay, this is the business logic. So public means access specifier, guys. Everyone should be able to access. Int means +1, -1, 0. If it's positive number, right side, negative number, left side, 0, discard. So that's the thing. And the method name is compare. And since I am going to compare two student objects, it accepts student X and student Y here. So now X is nothing but, okay, X is nothing but object to be inserted. Okay, object to be inserted. Okay, and Y is nothing but already existing object. Okay, already existing object. Clear everyone with the process? Already existing object. So I am telling return. Why return? Because int is the return type. The X is nothing but the object to be inserted. So the object to be inserted's age minus Y is nothing but the already existing object. So the already existing object's age here I am trying to subtract. This is the logic. So now for the very first time, okay, for the very first time when I tell, okay, the first time is step number 1. T dot add of, I am telling S1. So it means 111. So the first object will get stored as it is. S1, that is nothing but 111 will get stored as it is. Okay. Second step. T dot add of, okay, S2 and that is nothing but 222. So now here when you add an object into tree set, by default it will go in search of compare to method. But now since you have made use of comparator, it will go in search of compare method internally. It will go in search of which method? Compare method. This compare method is accepting two arguments, X and Y. So now X is nothing but the object to be inserted, that is S2, that is nothing but 222. Okay, X2 that is nothing but 222. And Y is nothing but the already existing object, that is nothing but S1 and that is nothing but 111. So internally what happens over here, guys, see here. In the first example, you'll not understand it immediately, okay? So you have to just understand the working procedure of it, okay? Because this is the structure that Java people have designed it. Okay. So now here, because see here guys, I mean, it's too early for you all to, question something like this here. Okay. Why does it call compare to method? All this, see here, simple terms. By default, okay, when you add an object into tree set here, it should call compare to method. Correct? It should call compare to method. But we are not making use of comparable in this particular scenario. We are not making use of comparable. I am making use of comparator. Why comparator? I will tell you later, not now. Okay, not now. I'm not going to tell you now. Okay, why comparator, sir? I'll tell you later. Why comparable? Why comparator later? Okay, but as of now, we are trying to compare student objects based on age and sort them. But I don't want to make use of comparable. We can sort in two ways. With the help of comparable, we can help of comparator. We understood comparable. Now we are supposed to understand comparator, and then I'll give you the differentiation. When comparable, when comparator, everything I'll tell you later. But we understood the working flow of comparable. Now we are going to understand the working flow of comparator. Why this sir? Why that sir? Later, not now. Okay. So whenever we want to make use of comparator and sort the objects here, rule number one is to create a new class. Okay. That has to implement the comparator interface, not comparable. No comparable. Don't take the name called as comparable as of now. Okay. It's only comparator. So I created a new class that implements comparator interface. And second step, I have to specify the generics type of which objects I am going to compare. Clear? Student. As of now, I'm working on a student project. So it's student. Since it's a predefined interface, we are supposed to, import that comparator part. We are supposed to import it. Clear? And then I have overridden. See, comparator has an abstract method called as compare. So when a class is implementing an interface, we have to override the compare method. So the student X means the first object which is getting inserted. X is nothing but the object which is getting inserted, and Y is nothing but the already existing student objects. Therefore, I write the business logic of sorting. It might sound very simple, x dot age minus y dot age. But if you don't understand the working, this might go over your head only. So three rules done. And the fourth rule is, if I do not pass, okay, if I do not pass the constructor, I mean, if I do not pass over here, now I will get here what? I will get here exception only. I'll get the exception only. Why? Because here I have not told, okay, tree set will always go in search of compare to method by default. But have I made use of comparable and compare to? No. I have written the business logic of sorting in some other class. Therefore, I have to create an object of that class wherein the business logic is written. Okay, I will create the object of the class wherein the business logic of sorting is written. And I will pass that object reference called as age. So when I'm passing the object reference called as age to the tree set over here, he will understand that, okay, I shouldn't go in search of compare to method now. I have to go in search of compare method. See, when I just tell over here, new tree set of, see, it is accepting comparator over here. See, in this specific third scenario here, constructs a new empty set sorted according to the specified comparator. So, specified comparator in the sense here, I am calling the business logic of sorting, comparator. So, sort students by age is a comparator, correct? It implements comparator is a comparator. So, the logic of sorting is written over here. So, now the comparator, I mean the tree set will go in search of the compare method, not the compare to method. Clear? So now here, this is what is happening. Three student objects got created, S1, S2, S3. Now we are talking about compare, okay? X is nothing but the object to be inserted and Y is nothing but the already existing object. So when I tell, S1 here for the very first time over here, S1 will get inserted. S1 will get inserted successfully. Now here, when I tell add here, it will not go in search of compare to. Why? Because we are making use of comparator. It's compare. So compare, it is accepting x comma y, two student objects. X is the object to be inserted. Which is the object getting inserted now? S2, which can also be called as S222. And y is nothing but the already existing object. That is S1, 111. And what am I returning over here? Returning x dot age minus y dot age. What is x here? X means S2, S2 means 222. What is S2 dot age? It is 23. So 23 minus Y. Y means S1, S1 means 111. What is 111 dot age? S1 111.age, it is 22. So 23 minus 22, it's plus 1. Plus 1 means RHS, it goes towards the right side. So over here in this particular data, it goes towards your right side. S2 will get stored over here, wherein the address is 222. Clear? It goes towards the right side. Now for the third step, okay, for the third step here, I will do the third step over here. Okay, somewhere I'll do the third step. Wait for it. Yeah, I'll do the third step over here. Okay, so I'll just maximize the screen here. Yeah, so I will tell t dot add of. I am telling s3. S3 means third object. 3333. I am adding the third object. Clear? So now it will go in search of compare method, not compare to compare method. Okay. Now in this specific data over here, okay, first part, compare. Now it is adding what? X and Y. Two student objects it is adding. So X is nothing but the object which is going to get inserted will get stored. So that is nothing but S3, that can be referred as 333. Y is nothing but the already existing object. But what is the already existing root node here? The already existing root node is S1. So therefore, it should always get compared with S1, that is nothing but 111. So now x dot age minus y dot age. What is x dot age? X is S3, S3 is 333. What is 333 dot age here? It is 21. So 21 minus y means S1, S1 means 111. S1's age here, S1's age is 22. So 21 minus 22 is minus 1. If it is minus 1, it goes towards the left hand side. So therefore, what happens over here? So S3 will get stored towards the right side, that is 333. So now what happened here? What is the age of S1? See, the age of S3 is 21, this is 22 and 23. Left node, parent node, right node. 21, 22, 23. It is sorted accordingly here. So we are trying to sort the objects based on the age here. So therefore, when I executed, is it sorting based on the age here? 21, 22, 23? Yes. So I just want you all to understand the working ashte. Okay, nothing else here. Just understand the working. Why, sir? That I will tell you later. Okay, not now. Okay, so this is all about it. But now, sir, there is a possibility that I can sort the name on. I can sort the uh, student objects on name also. So how will I do it over here? Okay, I will tell you here. Okay, see here. If I want to sort the name, student age on this, I mean student objects on the name, I will create a new class. Control N. I will create a new class, and the new class name is sort. Okay, students by name. Okay, I create a new class by the name called as sort students by name here, and I tell finish. Okay, and I tell finish. So now once we create that class, I designed a new class. I created a new class that will implement which interface now? That will implement the comparator interface, not comparator, comparator. And comparator is present in java.util package. I will import it. And what is the element type, the object I'm going to compare? Student. I'm going to sort student objects. So it will be student. So two rules done. Created a new class that will implement the comparator interface, imported it, specified the generics type, everything done. But comparator is having one abstract method that is called as compare method. It is nothing but compare method. Okay. And compare method will accept two arguments. Student X, that is nothing the object to be inserted, and student Y, object to be, okay, object to be already existing object. The access specifier is public so that everyone can access it, and it returns int value, that is +1, -1 and 0. Now over here return x dot name, the current object's name minus already existing object's name here. But if I use subtraction over there, how can you subtract names here? Can you tell Dinga minus Guldu, Tom minus Jerry? You can't, right? So now internally, okay, internally, what am I supposed to do now? We cannot separate names, right? Okay, we can separate age here. numbers. How will you do it here? We can't do it, no? So that's the reason here internally, we have to call the compare to method in the string class. Strings will always implement the comparable interface and it has overridden the compare to method. So therefore, I am taking the help of compare to method present in the string class. So I have told x dot name dot compare to y dot name. I am comparing the object to be inserted student's name with already existing student's name. Okay. So now when I go back over here, I will just give the names as different. B, I'll write it as C, just for tracing part, guys, just for tracing part. Now when I execute it over here, it is sorting based on the data here. Yes, okay, so here it's sorting here. I'll give the age as 20 over here, and I'll give it as 24 over here, and that way. So now when I just execute the program over here, is the sorting happening based on the names here? No, the sorting is happening based on the age. So if I want to sort based on the name, I have to create an object of the class wherein the business logic for name is written. Okay, I will create an object of the class wherein the logic is written. That is nothing but sort students by name. And I have to pass that respective object reference. I have to pass the object reference of name. So now when I execute it, the sorting is happened based on the names here. So that's how, we are supposed to use it for custom sorting. Why, sir? I will tell you. Wait. Let us try to understand the working of it. Okay, let us try to understand the working of it. Okay, see here. Wait, 2 minutes. Okay, until and unless I explain, no, you will never ever get the clarity here. Okay, see, first of all, imagine there are three student objects. This is student 1, this is student 2, okay, and this is student 3. So there are three student objects. Okay, now, so this is S1, that is nothing but 111. This is S2, 222. This is S3, that is nothing but 333. Clear? So what are the names in S1 and S2 here? S1 dot name is B, okay. S2 dot name is C, and S3 dot name is A. Correct? There are three students, S1, S2, S3. Addresses are 111, 222, 333 respectively, and the names are B, C, A respectively. So now here, I am telling the first step. T dot add of. Okay, I am telling S1. So what happens here? The first student object will get stored here. What is that? S1 is nothing but B. So B will get stored here. That is nothing but S1111 B. Okay. Now when I try to add the second object, T dot add of, I am telling S2. So now internally, it will not call compare to method. It will call compare method. So compare method is accepting two arguments. That is x comma y. So x is nothing but the student object going to be inserted and y is nothing but the already existing student object. So x is nothing but the object to be inserted, that is nothing but s2, and y is nothing but already existing object, that is nothing but s1. So now I am telling x dot name, okay, dot compare to, okay, compare to y dot name here. So when I tell x dot name, that is nothing but s2 dot name is c. C dot compare to, okay, y dot name. Y is nothing but s1. S1's name is b. So I'm comparing it with b. So c is greater than b. That is nothing but 66. Oh, sorry. 67 is greater than 66. And 67 minus 66 is always a +1, positive value. So where should the control go? It should go to the left side. So C will get stored here. So therefore, in simple terms, this is S1 and this is S2. Clear? Now again, when I tell the third step, T dot add of, okay, S3, I am adding the third object. So internally, which method will get called? Internally, compare method will get called here. And this is accepting two arguments, X and Y. So X can be referred as S3. Why? Because S3 is the object going to get inserted. And Y is nothing but already existing. Already existing are two objects. Okay, S1 and S2. But always the root node, that is S1. So S3 is nothing but X and S1 is nothing but Y. So what is X dot name? X is nothing but S3, right? S3 dot name is A. A dot compare to, okay. Y is S1. S1's name is B. Okay. So A is nothing but 65. Okay. B is nothing but 66. 65 is lesser than 66. 65 minus 66 is minus 1. So therefore the control goes towards the left side. A will get stored. That is nothing but S3. So what is the, order, sorting order? Left node A, parent node B, right node C. A, B, C. It is sorted in natural sorting order. That is ascending order. So this is how we are supposed to understand the business logic of sorting here. So when I execute it, is this data sorted accordingly here? Yes. So that's how we are supposed to understand the working of comparator. Okay. But why comparator, sir? I will tell you guys at the end of the session, you'll have the clarity here. Okay. Nah? So just understand the process. Let us try to do one more program here. Okay, we'll take the class as employee. Okay, we'll take the class as employee. Okay, class name is employee, and each and every employee will have ID. Each and every employee will have name, and each and every employee will have salary. Clear? And I will initialize it all the data with the help of a constructor. And I will override the toString method also by printing the age, name and salary. ID plus give a space plus name plus give a space plus salary. So we have overridden all the respective attributes here. So every employee will have three attributes, that is ID, name, salary, and we are initializing it with the help of a constructor, and we have overridden the toString because I do not want the string representation. I don't want some address to be printed. I want some nice beautiful sentence to be printed. Okay, that way. Now I will have one class called as sort employee. We are going to sort employee. Okay, so now when I tell sort employee over here, I will have my main method. I can, okay, create an object of tree set t equals to new tree set of, I'm just creating an object of tree set. Okay, so now over there, I will add two objects of student. Okay, see, employee E1 equals to new employee of, I can write the ID as 10, okay, and the name I can pass whatever I want here. Okay, I'll just write it as Ambani over here, and salary is, I'll just pass randomly 29.45, that way. So this is one way of adding an object. Okay, this is one more. Okay, I'll create two objects. Here I'll just give it as, okay, 30, and here I'll write it as, okay, a Birla here. Okay, so here I'll just write it as 23 point, okay, 67 here. Okay, done. So again, I can add t dot add of E1. I'm adding employee 1, t dot add of E2, employee 2. So now I want to add only employee objects. So I will specify generics here. Hey, tree set allow only employee objects. We have already done all these guys. Okay, it's not a new thing which I'm trying to do now. We have already done this. Okay. So over here, I will just add it as employee. So this way is also possible. And I can also add an object like this. New employee of ID is 20 and the name I'll just give it as Tata here. Okay. And here I'll give the salary as 56.98. So we can add the objects directly, or else you can create an object, store the address, and then add it. Oh, that the choice is yours. It's not a matter that you have to use the first way of approach or this way of approach. Anything is fine. Okay, so I'll just add this as 15. Okay, 15 is his ID, and we'll just give it as Godrej over here. Okay, or else we'll give it as Kotak. Okay, so yeah, okay, here I'll just give it as 78.34. Okay, some random data here, I'll just write it over here. Clear? So now I have added, okay, three employee objects. So what type of objects I'm going to traverse it? It's always employee colon from the tree set T. So now when I just try to print the object reference, just observe the program. What will be the output as of now? This is my program, simple Java program here, okay? No complications, nothing. I have an employee class, three variables, initialized it with the help of a constructor and overridden the toString to get the data. I create employee objects, add it into the tree set. Okay, you can do it that way. You can create the reset object and add the objects directly and traverse it. But now when I try to execute the program here, I will get class cast exception. Why? Sir, as of now, by default, once you add an object into tree set, okay, it will go in search of compare to method. Okay, is there compare to method in the employee class? No, we don't have compare to method in the employee class. Therefore, it's giving an exception. So what are we supposed to do? So we have to make the employee objects as comparable in nature. They should be sortable. They should be comparable based on one criteria, and they should be able to sort as well. So what are we supposed to do? With the help of comparator, I need to sort them. So I have to design a new class. Control N, sort employee, sort employee by ID. I'll create a new class called as sort employee by ID. Implements which interface? Comparator. Okay, and specify the generics type as employee here. Okay, and specify the generics type as employee. So now we have to override one abstract method. What is that abstract method name? Public is the access specifier, int is the return type, the method name is compare. And over there, it is accepting employee X, comma, employee Y here, two employee objects. ID means its number. X dot ID minus Y dot ID. So I have provided the business logic of sorting. So what have I done? I created a new class that implements the comparator interface. I have imported it and I have specified the generics type, element type as well. And I have overridden the compare method by providing the logic of sorting here. So now here, when I try to execute the program here, it is not sorting at all. See, still exception. Why? By default, as of now, still tree set goes in search of compare to only, comparable, compared to. I have to create an object of the class wherein the sorting logic is written. Okay. So I create an object of the class wherein the sorting logic is written, and I have to pass the object reference over here. So once I do it over here, the sorting will happen based on the ID now. See, 10 Ambani, 15 Kotak, 20 Tata, 30 Birla here. So I'm sorting based on the IDs here. Custom sorting. I want to sort based on the ID, so we are sorting based on the ID. Now over here, if I want to sort based on the names, how will I do it here? If I want to sort based on the names, I again have to create another class. Class name is sort employee by name here. Sort employee by name here. So I create a class that implements comparator interface. I imported it and the generics type is employee. And we have to override one method. What is that method name? Compare. Okay. So here it is telling O1. I'll just take it as X. I don't want O1. Object 1, object 2. Okay. X here, Y here. And what is the logic of sorting here? X dot name. I cannot use minus. I'll tell dot compare to by dot name here, because all the wrapper classes and the string class by default will implement the comparable interface, and it has overridden the compare to method. Okay, so that's the reason. So now I go to sort employee here. Now when I execute it over here, the sorting, is it happening based on the name here? No, see, Ambani, Birla, first and last. It's not sorting based on the name here. So if I want to sort based on the name, I have to create an object of sort employee by name. I have to create an object of that class, and I have to pass that respective object reference. So that object which I created, I have to pass it. Now I can delete this first line if I want it. Okay. So now when I execute it, see here, the sorting is happening based on the name. Ambani, Birla, Kotak, Tata. Okay. So always the sorting is happening based on the data here. Okay, so this is what we are supposed to understand here. Okay, got the clarity here? Okay, similarly, if I want to do it in descending order, if I want to do it in descending order, what will I do here? See, ID, this is ascending order. Okay, this is nothing but ascending order here. So if I want to do it in descending order, guys, any idea how will I do it here? In order to do it in descending order, this is ascending order here. So if I want to do it in descending order, you already know it, right? Last session we did. If I tell x dot id, I'll get this. So if I just reverse it, x dot id minus y dot id, it's ascending. So if I do the ulta of it here, it becomes descending order. Okay. So the reverse of it, it's nothing but descending order. So now when I execute it here, oh wait, I have to pass the id over here. So when I pass the ID over here, see here, the sorting is happening based on the IDs in descending order. So that way we have to just analyze and understand how we are supposed to do it here. Okay. Again, for the names also I can do it here. For the names also, I can do it over here. Okay, so what is the small change I have to do here? I have to just make sure x dot name will become y and y dot name will become x here. So therefore, now if I just compare it based on the name here, the sorting will happen based on the names in descending order. See, Tata, Kotak, Birla, Ambani. So that way we are just supposed to understand the sorting over here. Okay. Got the clarity here? So this is called as the sorting part. But now the most important part over here, I told you in the last session, sir, how do we compare based on the double value, decimal value here? Okay. So then what are we supposed to do here? Okay. So there is one more question which I'll answer here. Don't worry about it. Okay. So yeah, I'll let you know here. Don't worry. Okay. I'll answer to all your questions here. So how will you sort based on the decimal values, guys? So we'll create one more class. Sort employee by salary. Okay, sort employee by salary. Okay, you created a new class. It has to implement which interface? Comparator. Implements comparator. Okay, so which objects are you going to compare? Student. So, which method should you override over here? We have to override. Okay, just a moment. We have to override compare method. So here I'll just take it as x over here and I'll take it as y over here. So here if I just want to tell x dot salary. Okay, so if I just write it as x dot salary minus y dot salary here, I will get an error. Why will I get an error over here? Because the return type is int. So if I want a logic for comparison over here, long back, when we did this tree set over here, I told you one example over here when we did this tree set here. What was the tree set I told you? I don't remember where did I write it down. Solution. Somewhere I did this program for you all. Main class, correct. Okay, this is the data here, what I did over here. In the last part I told you, if I want to compare based on the datas here, I have to make use of the wrapper classes, because each and every wrapper class and the string class will have the compare to method overridden. See, double is a wrapper class, it has the compare to method overridden. Integer is a wrapper class, it has the compare to method overridden. And string also, it's a class, it has the compare to method overridden. Correct. Similarly, I have to call the compare. If I cast it, it will compare only based on the non-decimal values. So I have to call the compare to method over here. X dot salary dot y compare to y dot salary. I have to call the compare to method on the double class. But at the bottom of the screen, can you see? Cannot invoke compare to of double on a primitive type double. So it's telling as of now, okay, the salary is primitive double. See here, salary is what? Primitive double. So I have to just change it to uppercase D. If I declare it into non-primitive over here, internally what happens over here? We can call the compare to method of the double class. Okay. So now if I go back over here, I can tell sort employee by salary. Okay, I'll just pass it as salary equal to new sort employee by salary. and then what am I supposed to do over here? I have to pass the salary over here. Even if all the, if all the datas are having the same salaries here, but there is a change in the decimal values here, the comparison logic is written over here. So now when I execute it over here, see, the sorting has happened based on the decimal values. Non-decimal values will have the same value. If I cast it, only the non-decimal values will get compared. So that way we are just supposed to evaluate and understand the working procedure. Similarly over here, I can call the compare to method of integer class as well. See here, I can just tell here, okay, rather than doing it here, I can just tell y dot compare to x. Okay, I can just call the compare to method of the integer class. But if I try to do this entire process, no, it's if I just hover on it, it's telling cannot invoke compare to of int on primitive type int here. So why? Because in employee class I have declared it as int here. So which is primitive. I cannot invoke the compare to method and all. So I have to just write it as integer. So now when I execute the process over here, did I get the expected output over here? See, I got it in same thing. Okay, it's sorted based, oh wait, it's sorting. If I want to sort based on the ID here, I'll pass it. See, it will sort based on the ID in descending order. Okay, this is how we are just supposed to analyze it and try to get the expected output here. Okay, so just look at the business logic, guys. We have an employee class. We have three variables. We initialized it with the help of a constructor, and we have overridden the toString method. So now when I tell sort employee by, sort employee, we have written the main class. We have created employee class objects, added it into the tree set, and we are sorting it. That's it. But I can sort based on the ID with the help of comparator logic. I can sort based on the name, or else I can sort based on the salary here. I can sort based on whichever criteria I want. So that's how we are supposed to I understand the working procedure here. Okay, so this is all, we are supposed to understand the working procedure of comparator here. We know how do we compare ascending order, descending order, and we know here how do we call the compare to method as well. Because if I have the non-primitive reference, see double here, I can call the compare to method. See, it's telling compares to double the object numerically. The comparison operators are lesser than, greater than, blah 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 blah. So that way, it's just returning object. If you want to look at this, you can just look at the source code. You'll get the complete data here. Okay. So this is all about the entire process here. Okay. It's just that you just need to practice it a couple of times here. I'm just going to upload the videos here so you can practice it. Clear? So I'll tell you the difference now. Okay. Between when do we choose comparable, when do we choose comparator, and what is the difference here. Before that, anyone having any questions here, please do let me know here. Okay. Anyone having any questions here? Any questions? Any questions? Okay, great. Okay, so try to watch the video. Okay, once again here, and if at all you come across any drawbacks here, let me know here. Okay, so we'll try to sort it out. And there's one question here, sir. What if my what will be the binary tree? Okay, tree set if my data is B, C, A, D. If this is the insertion order, it's very simple. B will be over here, first object, then A will be over towards the left side, and C will be, if B, C, A, right? Oh yeah, correct. C will be over here, and D will be over here. So what is always the data? A, left node, root node. So A, B will come here. It comes towards the right side. But does it have a left node here? No. So the parent node will consider C and then D. So the answer will be A, B, C, D. This would be the order here. Okay, A, B, C, and since C is greater than is D, so it goes towards the right side. So sorting order is left, parent, right. Left, no node, so parent, and then right here. So that would be the sorting order here. Okay. So I hope you got the clarity about this as well. Okay. In case of BADC, doesn't matter. Okay, it doesn't matter, guys. The sorting all it will happen here. If it is B, it's over here, and if it is A, it goes over here. Okay, and if it is D over here, it goes over here, and if it is C, it goes over here. So what is the sorting logic here? Left node A, so you deleted. Parent node B, B got deleted. It comes towards the right node. But do we have any left node here? Yes. C will get considered, then the parent node D here. Okay. So this is what we are supposed to understand here. Okay. So I hope you got the clarity. Okay. So yeah, Mahanti, whatever you told here, okay, this is what the actual part is. Okay. So now we got the clarity about how the working is happening. The major differences over here is, okay, comparable, okay, comparable whenever we talk about, right? It is present in java.lang, okay, java.lang. But whenever we talk about comparator, where is it present? Java.util, okay, comparator is present in java.util. So now in comparable, we have a method called as compare to, okay, and in comparator, we have a method called as compare here. We have a method called as compare here. So now here, comparable is always used for default sorting. So default sorting means, I will tell you what is it. And comparator is always used for custom sorting. Default sorting, custom sorting. Imagine guys, okay, there is a huge sale going on Flipkart, Amazon, right? Okay, there's a big billion day, a lot of things happening over here, right? Okay, the great Indian sale, what is happening. So now imagine here, you go to Amazon, okay, you go to Amazon over here, you want to purchase mobiles, okay, you want to purchase mobiles. As soon as you go to mobiles over here, do you have an option called as sort here? Low to high, high to low, popularity, okay, relevance. You'll have so many options here. So that is called as custom sorting. Custom sorting meaning we are going to sort the objects based on one particular data. Is it low to high, ascending order, high to low, descending order, based on the popularity, based on the ratings here. So we are going to perform custom sorting. Internally, these are all making use of comparator. We are sorting the mobile objects based on custom sorting. Okay, I want to sort based on low to high, high to low, popularity, whatever it is there. Okay, that way. That is called as custom sorting. The user is wishing to sort it. But now similarly, as soon as you open Amazon, and you just click on mobiles here, you'll have so many mobiles here, M1, M2, M3. It is automatically in one particular order, no? It is automatically in one sorted order, no? Okay, so that is called as default sorting. As soon as you open the mobile application and tell mobiles over here, you will get the objects in one particular sorted or one particular order. That is called as default sorting. Automatically, it is sorted based on one particular manner. So always whenever there is default sorting involved, you will always make use of comparable. Custom sorting, you want to sort based on the price here. You want to sort based on the brand names here. So that is custom sorting. You want to sort it based on the requirement. So you can do it that way also. You go with Swiggy. Okay. If you go with Swiggy here, as soon as you search hotels over here, hotels near me, okay, near me, as soon as you tell hotels near me, it will just give the hotel details in one particular order here. That is called as default sorting. Okay, you open Swiggy, you tell hotels near me. As soon as you tell hotel near me, you'll get 10 hotels here. But it is already in one particular order. Did you sort it based on one particular order? No. So it's already there in one particular order. So internally, this default sorting comparable has been used here. As soon as we tell hotels near me, it is going to sort. Okay, it's not this is not the sorting logic. Hotels near me, I'll get the data. Now, if I want to sort it over here, I'll tell sort based on 4 kilometers. It should be based on 4 kilometers only. The price should be below 500. Okay, you're trying to sort it over here. Okay, so that way, custom sorting here. Only veg food, only non-veg food. Okay, only snacks here. That way, we are sorting based on the particular data. That is called as custom sorting. So comparable is always used for default sorting. Comparator is always used for custom sorting here. So that's what we are supposed to understand over here. Clear guys? So in an interview they'll ask here, okay, as soon as if see in the logic over here, see over here, when I make use of default sorting a few days back here, as soon as I tell car, see, as soon as I keep on adding the object, see, I don't have to do anything. I created car objects, and when I added the car objects into tree set, it is automatically sorted on one particular order, wherein the logic has been written in the same class. It will sort in based on one particular order. But now in custom sorting here, I can sort separately. They're all independent classes, no dependency. Okay. See, sort ID is separate, sort name is separate, sort salary separate. So they're all independent entities. So that is used for custom sorting here. So this is major difference between comparable and comparator. Comparator will make use of compare method and comparable will make use of compare to method. And comparable is used for default sorting and comparator is used for custom sorting. I can use it on based on one particular data here. Clear? So this is all about the entire process, guys. Okay. So anyone having any questions in today's session here? Anyone having any questions in today's session? I'm gonna upload the video here. Okay. Make sure, try to do it, try to get to know it, because I'll tell you what, if you want a job in any product based companies or any companies, whichever, this question is mandatory. What is comparable? What is comparator? Can you write a program with respect to comparable? Can you write a program with respect to comparator? And custom exception. So these questions are mandatory questions here. You like it, you don't like it, you have to be a pro at it. What is it? Comparable, comparator, custom exception. So these are the most important topics here, and I have done all the three, correct? So it's time for you to learn it. Okay, so tomorrow hopefully I will complete with collections. Okay, tomorrow if I finish with collections here, wherein we can see maps here and a few topics which I'm left out, like stack and queue, we'll try to see like 10 minutes topic, not more. Okay, and iterators as well, we shall try to complete it tomorrow. And after that, again 3-4 sessions left out, we will be done with entire Java for you. Okay, files and threads, 2-3 sessions, it's sufficient. We would be done with entire Java. Okay, so make sure start practicing it here. Okay, so it's going to be really important for you all to get interviews here. Okay, so great guys. Okay, it's time for you all to prepare for mock here. I'm going to schedule it anytime soon here, and you fail to give mock here, never ever get have hopes of getting interviews here. Okay, you do well in mock, you give mock here, absolutely I will help you out in order to get you all placed. Okay, if you don't give mock here, it's like no use, right? Attending the session, you don't give mock, how will I understand how good you are? Correct. So I have to understand where are the things you need to improve on, where you're good at, so that I could at least guide you. Okay, so that you won't make the mistakes in the interview. Okay, so start preparing here. I'm going to schedule a mock anytime soon, final mock. Okay, so it's going to be useful for you. Okay, so great guys. Okay, so we shall wind up a session for today and catch up tomorrow. Okay, so thank you all, take care, bye bye, have a nice day.